Hello, Professor. Okay, we made it to the last question. Let's get to it. I'm gonna share my screen with you and let's tackle this. I'm not going to read the question. I'm just gonna go straight to the solutions. I'm gonna fill out the information. This is data that we were given. The first one is this fixed cost. The fixed cost to produce a doll is 105,000. Okay, let's put it there. And then the variable cost, which includes material, labor, and shipping cost, is 30 per doll. Then during the dolls sell for $42 each. And if FTC overproduces the dolls, the excess dolls will be sold in January to a distributor who has agreed to pay $11. These are surplus. If we produce more than what we sell, we will sell our dolls at $11. And then, okay, now for the demand, it says the normal probability distribution with an average of 65,000 dolls and a standard deviation of 14,000 is assumed to be a good description of the demand. So this is our demand. 60,000, 65,000. And now for the production quantity. Okay. Let's compare this to the sales quantity. Sales quantity should be the lowest value among demand and production quantity. So use mean to determine. This was the note that the professor left us. Okay. Um. So here the production quantity is 65,000, and the sales quantity is the minimum between these two values. And the revenue from sales would be our sales quantity times the sell price, and the surplus would be the production quantity minus the sales quantity. In this case, is 0. We sold everything, and the revenue from surplus should be 0 as well, because we sold everything. So it would be surplus times surplus price, 0. Now total revenue would be revenue from sales plus revenue from surplus. And total cost would be parentheses, variable cost times production quantity plus the fixed cost. Perfect. And now the net profit would be revenue minus cost. Okay, it looks good. Now we can move on to the second question, to part B. Create a two-way data table to compare the net profit using the production quantities of 40,000, 50,000, 60,000, and 7,000 with a variable cost of 30, 32, 34. What is the net profit for a variable cost of $32 and production quantity of 50,000 units? Assume that sales price will be increased to 45 while average demand and other parameters will remain the same. So we need to change these values. First one is the sales price will be increased to 45, and previously we were selling for 42, so it increased. Now the variable cost is set to be $30, $32, and it was $30 before. And the production quantity is 50,000, and it was 65,000 previously. So let's type it in. And the demand remains the same. Okay. The surplus price is also the same. The question says nothing, like none of these change. Let me double check this. This is the variable cost of 32. Okay. The 32 actually goes here. This is the fixed cost, which remain the same. Okay, perfect. And now we just need to do this again. What is the sales quantity? We can look at our formula. It was the mean among demand and production quantity. So let's do it again. Mean, demand, and production quantity. Now the revenue from sales is sales quantity. That's what we sold. And the sales price. Perfect. Now the surplus would be the production quantity minus sales quantity. Let's go and check how we did it in the previous part. Yep, we did it the same way. It is correct. Now revenue from surplus. Revenue from surplus would be our surplus times the surplus price. And then the revenue would be the revenue from sales plus the revenue from surplus. And the total cost will be parentheses production quantity times variable cost plus the fixed cost. And then the net profit will be revenue minus total cost. And I just want to go to the answers and see how we're doing so far. Yeah, we got 100% for part A and 100% for part B. We are missing the data table. So let's create it. Here, we're talking about the net profit. So let's reference this cell. And now we can select it in the table, go to data, what if analysis, data table. For the raw input, this is the raw input is the variable cost. So let's reference it here. And the column is the production quantity, which is this one, production quantity. Okay, let's click OK. And let's see, let's look at our data table. Yep, we have 100% now for the data table. So it is right. Good. Lastly, for part C, let's read it. Using the model developed for part A, create a simulation to model demand as a normal random variable with a mean of 65,000 and a standard deviation of 14,000. Simulate the sales of the Doogee doll using a production. I can see the rest. A production quantity of 65,000 units. Use the random numbers provided below to generate the random values of demand for 25 trials of your simulation and estimate the net profit. Hint, create a one-way data table to calculate the net profit for the normally distributed demand values you computed for your simulation. Okay. So let me look at the formula for this. This is the normal distribution. Okay, this part is important. So it would be, the demand would be, the outcome is equals norm dot IMB or inverse. We were given the probability, so let's reference it. We were given the mean of 65,000 and then the standard deviation of 14,000. So let's close it. We don't need to fix anything because we hard code the values. Okay, let's drag it down. Perfect. Okay, now we need to create a one-way data table for the profit according to these demands. So let's reference the profit from part A, and let's select the demand table and go to data analysis. Data analysis, what if, data table. And now we are looking at column, which is demand. So I wonder if I choose anything, because if I reference the demand from part A, will it modify part A and will change the values and we will get a wrong answer? That's what I'm thinking of. Now let's try. We got 100% for part E. So if it changes, it means we need to copy the information. Okay, this is the demand. Yep, demand. Let me read here quickly. Data one-way data table to calculate. No. Okay, let's see. Okay. Average, net profit, max. And for the minimum, we use the point mean. We have been using this formula a lot. And for the standard deviation is the standard deviation of a population. I'm sorry, the standard deviation of a sample because we don't have the whole population. Okay, let's look at the values and perfect, we did it right. Luckily, we got 100%. So now we have 100% for all question A. And let's look at the total value. Yes, we got 100%. Okay, that was pretty much it, Professor. Thank you.